All right, welcome. If you're building predictive models, or let's be real, if you're cramming for a data science exam, there's one concept you absolutely have to nail. It's all about how you split your data to make sure your model isn't just book smart, but actually works in the real world. Today, we're going to break down exactly how to do that. So let's jump right in.
Here's our game plan. First up, we're going to tackle what I call the cheating problem. It's the whole reason we're here. Then we'll walk through the 3 key phases of building our model, and we'll use a simple analogy: a study session, a mock exam, and then the big final exam. And to wrap it all up, we'll put it together into a winning workflow that you can use every single time.
Okay, so why bother? Why go through all this trouble of splitting up our data into all these little pieces? Well, it all comes down to avoiding one single massive pitfall in machine learning. I want you to think about it like this. Is your model actually thinking, or is it just really, really good at memorizing? You could have a student who memorizes every single question in a textbook, word for word. They'll ace all the practice problems, no doubt. But the second they see a question on the final exam that's even slightly different, they're going to bomb. That is the exact same trap we need to avoid with our models. And this whole problem, it's got a name, and you can bet this is gonna be on the exam. Overfitting. This is when your model gets a perfect score on its homework, but then completely fails the final. Why? Because it never learned the underlying rules. It just memorized the answers it was shown.
So how do we fix this? How do we train a thinker instead of just a memorizer? Well, the solution is actually pretty elegant. We set up a really tough, rigorous testing environment by splitting our data into 3 separate piles.
And this right here, this is basically the blueprint. You'll notice the ratio is pretty specific. The lion's share, usually around 60 to 70%, goes to our training set. Then, the other 2, the validation and testing sets, they each get a smaller, roughly equal slice of the pie, about 15 to 20% each. This split is the absolute key to the whole process.
All right, let's dive into that biggest piece of the pie first. This is phase 1. This is where all the learning happens. Think of it as the model's intense all-night study session. The training set is, well, it's exactly what it sounds like. This is the main textbook. It's the stack of flashcards. This is the material our model is going to use to learn everything it knows about the world. So, like we said, this is the bulk of our data. The model just churns through this data over and over and over again. And every time it makes a prediction and gets it wrong, it nudges its internal settings, its parameters, just a little bit, trying to get closer to the right answer next time. The whole goal here is just to learn the relationship between the inputs you give it and the final answer you want.
And look, this analogy right here, this is gold for exam prep. If you ever need to explain what a training set is, just remember this. It's the student studying the textbook and doing all the practice problems at the end of the chapter. It's where the learning happens.
All right, so our model has hit the books. It's studied hard. But here's the question. Did it actually learn anything, or did it just memorize? To figure that out, we need to give it a surprise quiz, a mock exam. And that's where our second data set, the validation set, comes in.
The validation set is our first reality check. You can think of it as the mock exam you take a week before the final. These are questions the model has never seen before, and how it performs here is going to tell us if that study session actually paid off.
Now this is critical. The model doesn't learn from this data. It only gets graded on it. This is our first real test to see if it can generalize, apply what it's learned to new problems. If our model gets a 99% on its training data, but only a 60% here on the validation set, that's a huge red flag waving in our face, screaming, overfitting. We also use this set to try out different strategies. Maybe a simpler model actually does better on new stuff. The validation score is what tells us.
And all this tweaking and adjusting, it has a fancy name. Another keyword for your exam notes: hyperparameter tuning. Think of these as the high-level study strategies, not the facts themselves. It's things like how fast the model should learn. We just turn these knobs and dials, and we keep whichever settings get us the best score in our mock exam, the validation set.
Okay, our model studied the textbook. It aced the practice tests. Now, it's time for the real deal. The final, high-stakes exam where we get its true, honest-to-goodness final grade.
And that brings us to the testing set. Now this data set, you have to treat it as sacred. It is completely new. It has been locked away in a vault this whole time. And this is the most important part. You only use it once, at the very, very end. This is the only way we can get a truly unbiased, honest look at how our model will do out in the real world.
This last little slice of data is our moment of truth.
After all the training, all the tuning, everything is locked in, we finally let our model see this data. Its score here is its final grade. But you have to be so strict about this. If you even think about using this data to tweak your model, you're cheating. You're committing a cardinal sin in data science called data leakage. And that brings us to another must-know exam term, data leakage. It's when information from the test leaks into the study process. Think about it. It's like a student who gets their hands on the final exam a week early. Sure, they'll get a perfect score, but it means absolutely nothing, right? It's fake. It's an invalid result.
So if you remember one thing, remember this. The training set is the textbook. The validation set is the mock exam. And the testing set, that is the proctored, high-stakes, no do-overs final exam.
Okay, so let's put this all together into a simple, winning workflow. This is your study guide for building models that you can actually trust.
It's a really clean 3-step process. Step 1. Learn the patterns. We let the model study the training set until it can't study anymore. Step 2. Refine the strategy. We use the validation set to tune our approach and pick the best version of our model. And finally, Step 3. Get the final grade. We unleash our finished model on the testing set to get its final official score.
Now, this slide right here, this is the whole enchilada. If you're studying for an exam, pause this, take a screenshot, whatever you need to do. It maps every data set to its purpose and to our exam analogy. Training is studying the textbook. Validation is taking a mock exam. And testing is taking the final exam. It really is that straightforward.
So why do we go through all this hassle? It's because this isn't just some classroom exercise. This strict, rigorous process is what allows us to build models that we can actually trust. Models that can make important, real-world decisions in business or science or medicine.
So, this whole process is fantastic for getting a final, trustworthy grade on our model, but it kind of begs a bigger question, doesn't it? How do we decide which student, which type of model, we should even send to the study session in the first place? That's a great topic for another time. Thanks for watching.